I thought of the title for this a little while ago, about using numbers in education research, and as I came to write it, I suppose I've changed it a little bit. It's probably a little bit more about using numbers in education policy, I think, which of course has important implications for education researchers as well. So I'm going to talk about education policy in England and how numbers, and in particular test data and examination data, shape education policy and therefore education research, and what education researchers can and might and maybe should do about it. To begin with, I thought I would tell you a little bit about my research. My background is as a chemistry teacher in high school. I taught chemistry for about 7 years while I was doing my PhD, and my PhD was in boys' underachievement. I was interested in a lot of discussion that we have in the media, in public discourse, in policy, about failing boys. And I wanted to examine whether it was the case that boys were failing, and if so, what could be done about it and why were they failing. Of course, boys are not failing, but the discourse and the discussion is very much about this failure. So when I moved then from teaching to work in university, I'm sort of interested, this is a wordle of some of my research papers and some of the books that I've written. These are the words that tend to appear most often, and I thought that it gives you an indication of the area that I work in. So I'm interested in schools, in education, in young people, in education policy. I'm also quite interested in science education, given my background as a chemistry teacher. And I'm also interested in broader issues of social justice, especially regard to education policy. With regard to research methods, I firmly believe, and this is something I will look forward to talking to the students about when we get started tomorrow, that the methods you choose should be driven by your research questions. So what you want to find out is determined by, the methods you use are determined or decided by the questions that you want to ask. Having said that, a lot of the research that I do has been using secondary data, so existing data, large-scale and small-scale data that already exists. And this is what we're going to be talking about over the next few days. And I thought that I would tell you a little bit about how I use that in my research. So that just gives you an indication. So what I'm going to talk about then. I want to talk about education policy in England and the role of numbers. It's a really interesting time in education policy in England. Not such a good time if you're a teacher, maybe. And today, 1 million public sector workers are on strike, mainly in England, and a lot of teachers are striking, not just because of pay, but also because of changes to the education system, and changes that are very ideologically driven. So it's a very interesting time to be a researcher, researching education policy in England at the moment. And I'm talking specifically about England. I'm from Wales. I taught in Wales and I did my PhD in Wales. But the system in Wales used to be very, very close to the education system in England, but now they're becoming more and more separate. So I'm deliberately only focusing on England today, which is becoming quite different from the rest of the United Kingdom. So I'm going to talk a bit about how policymakers, how the media, and in particular how education researchers in the UK use numbers. And I'm going to talk about, as I've said, using secondary data analysis as perhaps a middle way between those education researchers who use numbers all of the time and those people who never use numbers. And I'm going to give you some examples from my own research about how we could engage with numbers in a way that does not have to be very complicated. It does not have to involve a lot of difficult statistics and a lot of difficult numbers. So that's what I'm going to sort of end with. So a little bit about education in England then. I don't know how familiar you are with education system in England, but it is probably the case, I think largely the case, that English school children are the most tested in the world. So we have national tests at age 11, at age 16. school leaving age has just been raised to 17, and in 2 years' time will be raised to 18. So most students stay on in school beyond the age of 16, and everybody will have to up to the age of 18 quite soon. But it is a system that is heavily based around testing. Until about 7 years ago, we also tested students at 14. So national tests at 11, 14, 16, and then if you want to go to university at the end of school in the entrance exams to university around about the age of 18. And there are lots of other exams that students take, you know, coursework and assessments that are set by their teachers. But there is a huge amount of testing, is a big part of the curriculum in England. Linked with this is the idea of school accountability, and the idea that if schools do not meet targets for assessment, then those schools are held up to a great deal of scrutiny. In many ways it is similar to the education system in the United States with No Child Left Behind. I'm not sure whether you're familiar with the big changes in American education over the last 10, 14 years or so. But what they're doing in America is very similar to what has happened in England since the early 1990s. Lots of testing, lots of monitoring of students, and holding students, schools, head teachers and governments accountable for education progress. At the heart of this is the idea of choice, and this is especially true with the current government. We have a coalition government at the moment, but it's very strongly led by the Conservative Party, for whom the idea of choice and the parents' choice and the parents' right to choose the best education for their children is right at the very, very centre. So we have a system where, in theory, parents have a lot of choice over the idea of over the school that they want to send their child to. We report examination results for school in league tables. The idea being that schools report their examination performance, and parents can decide whether they want to send their child to a high-performing school or not. With that comes diversity and the idea of different types of schools. In 1988, we introduced a national curriculum. So we have, to some extent, a national curriculum from ages 5 to 16, where all students follow the similar curriculum. That's starting to change now, and some schools are not expected to teach all of the curriculum, but because the curriculum is so closely linked to exam data, many schools still teach important elements of the curriculum. So we're getting an idea of diversity, different types of schools. We're starting to have what we call free schools. The idea is similar to what happens in Sweden, very much influenced by the model in Sweden, where parents, communities, religious leaders, business groups can set up their own school. So a school which is funded publicly, funded by the government, but has a lot of freedom and a lot of autonomy over what they want to teach. And that has become quite controversial in England. There are only a few of these, there are only about 150 of these new schools at the moment, but it is a new policy and it's something that is starting to expand. So the idea that there is a lot of choice over the types of schools that parents or children can choose to send their children to. Along with this, we have expansion of higher education. I'll talk a little bit about higher education later, but the numbers of people going to higher education has increased, as perhaps it's done in Poland as well, but has increased greatly over the last 20 to 25 years. Tony Blair set a target that by, I think it was 2010, half of people aged 18 to 30 would go to some form of higher education. They didn't quite make that target, but it's around about 45% of people of that age group have some form of higher education. So higher education is big business. In the UK, higher education is largely public. Universities tend to be public. There are very, very few private institutions. It's not like the United States at all. So public institutions, but lots of big expansion in higher education. And something which is also interesting in terms of the way that education in England is developing is the role of the private sector and the controversy around having the role of the private sector in an organisation that is largely funded by the taxpayer, by public money. So there are some suggestions that we will have a general election next year, 2015. If the Conservative Party win the majority, there is a suggestion, we will see whether it happens, that some schools, publicly funded schools, free schools for example, will be able to make a profit. And that's very unusual. And what is happening is that more and more private organisations are becoming involved in the running of schools and in the management of schools and so on. And that's something that has happened over maybe the last 10 or 15 years or so. And that's something that is a little unusual. But I'm not going to talk a great deal about that today, but it's something that's changing in terms of the education context in England. I'm going to give you a few graphs, but I'll explain what this is. At 16, so until this year, at the end of compulsory schooling, students sit national tests. You may be familiar, old O-level, and since 1988 it's been called the GCSE, the General Certificate of Secondary Education. And this is what most 16-year-olds will sit just round about this time of year at the end of schooling. And this just gives you an indication of performance of students in this assessment. Now, we're very keen in England on measuring exam test data, and the exam results for the GCSE will be released at about the 23rd of August, around about that time. And the media goes crazy. It's a big event because we scrutinise our exam scores and we can see whether standards are rising or falling or have stayed the same. There's a lot of pressure to demonstrate progress and increased progress. And you can see by the graph that standards are rising. Largely, we measure whether schools have been successful or not on the number of students who get 5 passes in the GCSE. So students will typically sit maybe 8 or 9 GCSE exams and they're graded A star, which is the best, to G. So A, B, C, D, F, G. Students who get a C plus, that's the idea of the sort of the pass mark. So this is how quality is judged in schools, on the percentage of students who get 5 passes. So this is the data that you can see. And you can see that since 2002, standards have more or less risen. But there are gaps. And these gaps are apparent in every country. This is not something that's particular to England. The yellow line shows performance of girls. And in this assessment, girls outperform boys, which is the red line. And that has happened for a long time. The green line, or the orange line, or the brown line at the bottom, that is the children who have what we call free school meals. So we have an imperfect measure of poverty. It's not great, but if you're looking at patterns in education and you're looking at data and numbers in education in England or in the UK, then free school meals is the indicator of poverty. Because if families have a low income, then their children are entitled to have free school meals. They may not accept the free school meals, but they are entitled to that. So children who have free school meals tend to come from the poorest homes. And you can see that they perform less well in school. So schools that have high proportions or lots of pupils from poorer homes or have free school meals, they tend to perform at lower levels. They don't tend to do as well as schools in rich areas, in more wealthy areas, who have very small proportions of children with free school meals. And this is the same at every level, from early years, from entry in school to 5, through to the university that you go to. If you come from a poor home, then academically you are less successful, usually, than those who come from more wealthy homes. And I'm sure that's the same in Poland as well. It's the same in any other countries. Why the gap is closing is an important question. The performance of all students is rising, the gaps are closing, and the gaps between some groups are closing faster than others. We'll come back to one of the reasons why are these children with free school meals doing better? Are they actually improving, or is it the way we measure the exam scores? So on the one hand, it's depressing. It's not good, because if you come from a poor home, you tend to do less well academically in school. But the performance of all students, including those who are eligible for free school meals, is improving. This is only one measure of a successful education system, though. I'm sure you could all come up, each of you could come up with another different measure of how an education system can be successful, can be considered to be successful or not. However, exam scores are seen as being the most important. They are the most tangible outcome of schooling. And I don't think that's the same in England. I think it's the same in many, many other countries as well. But exam data and test scores very much dominate education system in England. They're not perfect, though, and this is one of the issues around education research and how we use numbers in education policy in England. So the graph that I just showed you showed great improvement. There are gaps, but the trend is towards improvement. But the numbers can only tell us so much. Each year we will be testing around about 500 or 600,000 students in a year group. Will be sitting these tests. There are going to be failures and problems within the actual testing system. However, they are treated, the data is treated as if it is as a universal truth when it comes to setting education policy. And we need to be a lot more cautious in how we interpret this data. So we have one of the people who's involved in setting the tests and setting the exams argues that we shouldn't be using these exam results in order to judge the quality of schools, especially comparing one year to the next year. Maybe it's okay for an individual student to sit the exam and to be judged as given a grade, but to measure it over time is problematic. Having said that, this is what the student exam data is used for in England. The list could be longer, but it wouldn't all fit on the screen. So not only does an individual student get an exam result, you've got an A in maths, an A star in English, a B in biology. They're also used for a whole range of other things. And this is where some of the issues come. I'm not arguing that exams are not good. I'm not arguing that it's not important to assess students. But we need to be cautious about how we use and interpret the data. So we use this data, the data that I've shown you on these graphs, year on year. We use this data to rank schools, to decide which is a good school and which is a bad school. We use the data to decide who is a good teacher and who is a bad teacher. And we decide how we are going to pay the teachers, depending on the performance of their pupils. Since the early 1990s, schools in England are inspected. So inspectors come in and they judge the school to be of good quality, of outstanding quality, or not good quality. And this exam data informs that decision. We use it to decide which schools are converted into academies. Academies is a new and important policy in terms of having more diverse schools in England. So academy schools are schools that have a lot of freedom to change their own curriculum. They're free from local government. So they're only accountable to the Secretary of State for Education. We have 3,500 secondary schools in England. Most of them are now becoming academies. And these schools work in competition with other schools in their area. I have a master's student who works in a small town with 2 secondary schools. And those 2 secondary schools compete for the best pupils. Because if they have the best pupils, they will then have better examination results, so they will be better ranked, they will receive better attention from government, more funding from government, possibly, and so on. So the schools now in the town, the two secondary schools in the town, compete for pupils. So and we use the exam data to judge school quality and therefore competition. If schools are seen to be not successful, they are converted to academies largely. It varies, the policy has changed. Most schools are now academies. This data is also used to calculate targets, both local for the schools, but also for national government. They're used to decide what national policy should be like in education. And they're used to decide how good our education system is nationally. So there's a lot of focus, there's a lot of emphasis placed on this assessment data. Several years ago, the Secretary of State for Education said that if students did not improve by, I think it was 8 percentage points, so if more students nationally did not pass the test, he would resign. And this is a test for 11-year-olds, so at the end of primary school, 11-year-old students will sit around about 5.5 hours of tests, national tests. They're set externally and they're marked externally, so completely separate from the school. So around about 5.5 hours of tests, which researchers estimate students revise for or prepare for around about 150 hours. So about 150 hours of the school curriculum in the year before these tests is taken in test preparation. And the idea being that these tests are fundamentally important for the child's future life. So the idea that if a child does not pass or get expected levels in these tests at age 11, it will be more difficult to recover later in life. Now that places a huge amount of unnecessary emphasis on these tests. There is no evidence at all to suggest that that's the case. It may be the case that students who are successful academically at 11 are perhaps more likely to be successful academically at 16, 17, 18 and beyond. But there's no causal relationship between doing well in a test at 11 and success in later life. But this is the sort of emphasis that is placed on these sorts of assessments. And if the education research community does not engage with this sort of data and does not use numbers, then how can we say that this sort of claim by the person who is in charge of education in the country is unwarranted? Because there is no evidence to suggest that. You cannot have a causal link between test performance at 11. Test performance at 11 does not cause good performance at 18, 20, 21, 25, and so on. And the Secretary of State, who said if standards do not improve, they will lose their job, lost their job. He resigned, or actually his predecessor resigned because he'd already moved on to a different job. So there's a big focus on the importance of national testing. So what impact has this had? It may be the same in schools in Poland, I don't know, and I'd be very interested in what you have to say about that. But the impact of what we call high-stakes testing, there's two questions we need to ask. The one of them is, for whom are the high-stakes testing for? The idea of an 11-year-old child having to sit 5.5 hours of exams after having 150 hours of preparation, that test result actually does not really make a great deal of difference to the next stage of that child's education career. It's different when you're perhaps 18 and you're sitting an entrance exam to go to university. If you don't get the grades, you don't get a place on the course. So it's much more importance to that individual. But it's arguable how important it is for an individual to be tested at that young age. And what we have is a lot of concern about what the negative impact that this testing has had. So for example, the people who set the tests, the examination boards, they are organisations, commercial organisations who produce the assessments. It is in their interest at GCSE, at A-level, for students to do very well. And so there is a concern, and there is a concern that the exams are becoming easier over time. It's very, very difficult to assess that. It's very difficult to know if you sit a maths exam in 2001, is that easier or more difficult than a maths exam in 2014? It's very difficult to know that because what we teach in school, how we teach in school has changed. So it's quite a difficult thing to decide. And if we find that it is easier, then what are we going to do about it? Why does it matter? Why should we care? It's not the student's fault. So whose fault is it if we do prove that exams are becoming easier? It is perhaps the case that exams are not easier, but they're different, and the way that students are prepared for exams are different. So what happens, particularly with examination boards, is teachers get a lot of support and a lot of help in how to prepare students for exams. So we've become very good at preparing students for tests. And perhaps that's one reason why we see the standards improving. From 2016, the examination system at GCSE at 16 is going to change in England, and that's going to have a big impact, because before we had this notion of coursework. So the idea being that you split the course into small chunks, and students study, they do some coursework, then they may have a test. So it's small pieces of information. So the way that we assess students has changed. And there is and what will happen from 2016 is there will be no coursework assessed. So students will only be assessed by examination at the end of the course. And that will have a big impact on the graph that I showed earlier. Well, it will be interesting to see what impact that has on the graph. There's concern about what we call gaming the system. What exam, by entering students for exams that may not be as difficult as others. So instead of entering students from the GCSE, you could enter students for other exams that are equivalent to the GCSE, but might be easier than the GCSE. Because it's very difficult to decide which equivalencies between different tests. And so this has meant that some schools, which are even heralded in the national press as being very, very successful, are very successful because they've gamed the system. They've entered students for exams that are less rigorous, but still count for important targets. Because schools want to be successful, because there's a lot of pressure on schools to be successful, there's a lot of pressure on teachers to be successful, and of course there's a lot of pressure on pupils to be successful. So the impact of high-stakes testing on the education system as a whole, and also on individual students, is actually quite problematic. That is not to say that tests and exams are not important, because they are important. But the important thing is what we do with that information and how we use that data. And I think that's the one thing that education researchers have an important role in engaging with. In addition to testing, successive governments have had this idea of fairness and social justice right at the very, very heart. And the idea that it is education that is the route to social justice, social mobility, and a fairer society. And there's a real paradox here. Because on the one hand, we would probably all sitting in this room argue that education is a good thing. And education can open up opportunities and life chances that may otherwise not be available. But education as being the fundamental way in which society becomes fairer and becomes more just, I think places a lot of emphasis on education. And in the current system that we have in England, that is done through test data and through exam results. So which are the schools that feel the most pressure to improve? If we are judging school quality based on a perhaps flawed exam and test system, the schools that are going to be under the most scrutiny and under the most pressure to improve are not the schools in the affluent, leafy suburbs. They do very well, thank you. They have good inspection results, they have good test marks. It is the schools who are in the more vulnerable areas or in disadvantaged areas, serving students who are eligible for free school meals, students from more vulnerable communities. Those are the schools that are under the extreme pressure in order to improve. And you could argue that perhaps that's a good thing. In America, the No Child Left Behind Act was essentially very, very equitable, because it argued that all students, no matter how vulnerable or how disadvantaged, have the right to a good education and have the right to improve. And I don't think anybody would argue against that. But the issue is how we judge the quality of schools and how we judge the quality of education. and the role that the state has in holding schools accountable, especially when they're based on these exam scores, which can be flawed and can be problematic, especially if we use them to judge performance and progress over time. I just wanted to touch briefly on Pisa. I'm not sure what the status of discussion around Pisa is in Poland. Pisa is something we'll talk about over the next couple of days. This extract here is from one of the very first reports or documents on education that was released by the current government when they came into office in 2010. This is one of the first things that they had to say about education. And what I think is really interesting from this quote is the idea is that what really counts is how we do in comparison with our other neighbours, with our other countries. So the fact that, I don't know, English 15-year-olds can, I don't know, have a mid-ranking position in Pisa, that is seen as an indication of a failing national school system. So, you know, it's interesting, particularly since this report over the last few years, Pisa has always been important. But more recently, there is much discussion in tying Pisa to the national curriculum. So the idea that what we teach in schools and what the knowledge that we consider to be important enough to disseminate to our young people in schools is going to be linked very tightly to the Pisa assessment and to what is actually assessed in Pisa. Already, the government links the A star, the GCSE pass rate to scores in Pisa and argue that English students are 5 grades behind students in Singapore or whatever country they've decided to compare us against. But that, I think, is quite a worrying trend. If you're comparing performance in Pisa, I mean, we can talk for quite a long time about the flaws and the benefits of using Pisa anyway, and hopefully we'll have some discussion on that over the next few days. But the interesting thing for me is how we equate a Pisa score to performance on a national test, on a national curriculum. And what is also a concern is that we lose the numbers. We move so far away in terms of discussing the rights and wrongs of Pisa and how we can't measure anything because it's all a bit too complicated. We move so far away from what these numbers actually mean. And what Pisa actually sets out to suggest, that if we went closer to that, we'd realise that such comparisons are meaningless. Having said that, very closely linked to economic competitiveness, our performance in tests nationally and in comparison to our competitor nations, is the idea that Pisa is now going to start to be setting the agenda for what is taught in schools in England. And I think that that's of interest to education researchers, but perhaps of concern to teachers. It kind of brings me to this idea of how we use numbers and how we consume numbers. And this kind of applies not just to academics, it applies to policymakers and it applies to the media. The English media is very vocal on education policy, and it'll be very interesting when the exam results come out in August, the tone that's set about our standards falling, our exams getting easier. You're kind of in a catch-22 situation, because if test results go up, it's because the exams are easier. If they go down, it's because standards have fallen. So you can't win. You go round and round in circles. But they're very engaged in this idea. And these GCSEs and these 5 or more A stars to C grades is kind of the benchmark of quality in terms of English education. And it's linked to how we engage with numbers. I'm not sure about the curriculum in Poland, I confess to say, but I would be interested in the level of mathematics that's taught in school. England, I think, is quite unusual. Not just England, Wales and Northern Ireland are quite unusual in that maths is only compulsory until the age of 16. So most students will have to sit one GCSE, one assessment in mathematics. And for many, that's the last maths they need to do. So I teach undergraduates, master students, doctoral students, who maybe have gone and studied sociology or education at university, and they will not have had to engage in any maths since they were 16. And that's not uncommon in England. It's uncommon compared with everywhere else, but it's not uncommon with England. And I think the idea is that we have amongst the lowest participation rates post-16, so after the GCSE, rates than comparable OECD countries. So only around about 13% of students do any mathematics. I think students who remain in education do any mathematics after the age of 16. And that, you can see, has an impact on levels of numeracy in higher education, particularly among social scientists, I would argue. And social scientists who've taken a sort of a traditional route where they may have studied social sciences as an undergraduate and so on, where they will not have had to engage in mathematics for a considerable time. And that arguably reflects on their choice of methods that they use if they decide to become professional researchers, but also the extent to which they engage in numbers more generally, and the extent to which the population is numerate and engages in numbers. There have been many attempts over the past decades to get more people involved in maths. And the latest idea is a target for universal participation in post-maths. So the government has decided that everybody has to do maths post-16. And this is going to be very complicated. Now that students have to remain in some form of education and training up to 18, there is an expectation that that they will have to continue to study maths. So they have this idea of having a new core maths qualification, which is proving to be quite controversial. But you can see that the extent to which if students are only engaging in maths, having to engage until they're 16, that's perhaps an issue of concern, yes. The majority of students who will go and study sciences will have had some post-16 maths experience, even if it may just be 1 year rather than 2 years. But I think there is certainly pressure amongst universities. I mean, I was quite surprised at some of the low levels of numeracy skills that, you know, very good students have, but that they forget the maths that they've done, and it's left a long time. And it's like, oh, I can't do numbers. It's the idea that, I mean, you know, it's acceptable to say, I can't use numbers. I don't do maths, in the way that you wouldn't say, I don't do reading, but you would say that you don't do maths. And that's very true. I mean, I can only really talk about social science, so sociology, education, undergraduates, but I think there is a pressure from universities. There's always a pressure from universities. And then schools have to respond. You know, when we start to do lots and lots of analysis, we tend to forget where the data has come from and what it actually means and what the social science is behind that data. And that's why, you know, social scientists have an important role in interpreting the sort of data and information that governments produce and use to judge national education standards and inform government policy. One of the things, this is, I'm not sure if you've seen this quotation before. This is, I mean, I don't know if you've come across Huff. It's the How to Lie with Statistics book. I think that's what it's called. But I like this quotation because this is often, I think, quoted back to me, not directly, but sort of implied by sort of many of my colleagues who would argue that often it's a short afternoon in front of the computer, produce this table of data, and you know, that somehow analysing statistics, analysing data is somehow a cold, objective, neutral pastime. That you do not spend hours agonising over what the data means or over the best techniques to use it or over the quality of the data, that somehow you are detached and neutral when you analyse the data. The paper that I mentioned to you that just recently got published, we've spent hours agonising over what this and these numbers actually mean and balancing the strength of the model between the coefficients. Does it matter if you get a strong coefficient if the model isn't very strong? You know, there's a huge amount of interpretation and anguish that goes on to interpreting sort of statistical outputs. You know, it's not a cold and objective pastime at all. But anyway, that's kind of sums up what is often the reputation. One thing that's being done about it, and if any of you, particularly doctoral students, are in, you know, quant basis. There's a big drive in the UK at the moment to employ more quant researchers. The Q-Step is a huge initiative. I'm not advertising the initiative at all. I'm not involved in it. I have nothing to do with it. But it's quite interesting that this idea of promoting quant methods in social sciences, not just in education, but social sciences more broadly, is something that has sort of got quite a lot of currency, certainly around undergraduate training and beyond. So it's quite an interesting time in that regard. Well, is the idea that you don't have to use numbers, but you should be able to consume numbers. And the idea that it's fine if you're not going to do some complex modelling because your research questions request that you go and talk to people. But you ought not to ignore evidence that is based on numbers and statistics. And I think, but in that, I think that social scientists and statisticians to some extent have a responsibility to make sure that they communicate their findings in a way that is accessible to what is often a general audience. And I think that even with social science statisticians writing in some journals, you think, and you could explain that. There are plenty that you could make, that could be made more accessible to a general audience. So I think it's more. But then there's also a responsibility on supervisors. I mean, I don't know what sort of doctoral experiences are here, but it's almost the case that when you start a doctoral program in many schools, not all, but many schools of education, the first thing you're asked to do is pick sides. Which side are you on? Are you an interpretivist or a positivist? And that at the very start of research methods training, doctoral training, is really problematic. With supervisors who say, oh, well, if you're going to use numbers, you'll have to find someone else to supervise you. That idea that you're one thing or the other is overly simplistic and I think problematic. But yeah.
If we look at more general question, if I can say something more, if you don't mind. If we look at more general problem of quantitative description of the reality, of the world generally, I think we've got more and more numbers everywhere around us, and in the media as well, on TV and newspapers as well. So what do you think about the, let's say, ordinary people? Do they, or parents of children, do they understand that living in such a world requires being able to interpret it and understand those numbers? And as far as I can observe, there is a growing let's say, there is a clear tendency of more and more quantitative description rather than qualitative. Okay. So there should be expectation that we will be able to understand it.
Mm-hmm. I completely agree. I think, I mean, the availability of data that you can, in terms of scrutinizing the data, even in terms of holding, your local policymakers to account, people all have to be able to engage and consume that data. Do they do it? To some extent. I mean, in terms of, I talked about league tables, which are explicitly intended for parents to use in order to decide whether that school is a good enough school in order to send their kids to. And it's the same, now they're moving on to such indicators in hospitals and doctor surgeries and so on. But the evidence suggests, at least in education, is that parents don't make a great deal of use of that data, or if they look at it, that's not the only piece of information. So, people can be sophisticated consumers. I don't know about the extent to which people do seriously engage in numbers critically. If they did, then they'd be holding newspapers like the Daily Mail to account, perhaps, for doing it, or not trusting the sort of. But then you get the argument that I don't trust any numbers. They're all lies. And then, of course, then that's a problematic. You have to be a little bit more sophisticated in engaging with the numbers than that, I think. But I think that I'm not sort of in any way about the quality of maths education in schools, because it's not about that. But in the extent to which, people continue to engage with numbers beyond schooling, I think certainly from the undergraduate students, who are bright students, often they've not really thought about it because their minds have been on other things. Maths has not been an important part of their life since they were 16. So to think, they're like, how do I calculate a percentage? I've got no idea. I haven't done that for ages. How do I read a table of data? How do I interpret a graph? That's the sort of level I think that we're talking at initially. And so I think that kind of lack of engagement is a real concern. So I want to kind of offer a sort of a middle ground between these two groups. So this idea where, you know, people are developing new statistical techniques, where, you know, it is about the numbers, it is about developing, you know, pushing the boundaries of knowledge in terms of what we can do in terms of analysing data and developing new techniques, as well as people who may not engage with numbers. And I would argue that one sort of middle ground is this idea of using secondary data. And really this has come from when I did my PhD and left teaching and went to work at Cardiff University. I was, as is often the case, working as a research assistant on what I thought was someone else's project, which was fine, but it wasn't my project. And so I was amazed at the availability of data that already exists, it's for free, and I can just go and analyse it. And that's really how I started to develop my areas of research interest. In simply analysing, I didn't have to spend time applying for grant funding, which I probably wouldn't get, in order to do research, because all I needed was the time. And I was fortunate enough on my project to have sort of a day a week or so on that I could spend on analysing this data. And so I would argue that particularly at the start of somebody's research career, this is a good way of starting to become more numerate if people are not intended to use numbers in their research. And this is a good way of getting into it. So what do I mean by secondary data analysis? I'm only talking about quantitative data. There are huge amounts of qualitative secondary data, you know, historical records, life histories, photographs, and so on, you know, existing data from some of the really big social science, you know, small-scale research, qualitative interview research projects that have been collected. So there's a lot of qualitative secondary data. I'm just going to talk about the quant stuff. So what can you do to it? Well, you know, it's data that has already been gathered by someone else. I think the key thing about secondary data is this: you haven't gone out and collected it yourself. That has advantages and disadvantages. And I'm not going to talk about those today, but we'll talk about them a little bit tomorrow. But you can use this data to investigate new analytical approaches. So some of this data was collected, for example, in the 1960s, where we didn't have the computer processing power that we do now. So, but reanalysis of that data is perfectly feasible using new techniques, or simply revisiting that data with new research questions. Testing different theoretical frameworks. You know, this can be very theory-driven, this sort of analysis, or it could be simply curiosity-driven. It could be driven by, you know, policy or by anything. You know, it's a broad area in which to work. I've included this quote because it sort of sums up why we might wish to think about using this sort of data. And I'm suggesting the use of this sort of data, not in order to do complex stuff, complex analysis, although, you know, often it's perfectly great to do that sort of analysis, but to doing it as sort of, you know, using relatively straightforward techniques. And thinking about it as a potential, particularly in doctoral study, as maybe the main method, or as a way of helping you frame your research questions, summarise the field, and so on. So there's lots of different potentials in which you might wish to use this approach. It is an approach that's not that widely used, though. What I've got here is this is a number of social science journals published in English. And these are the proportions of papers that used some sort of secondary data. And the blue lines, so for education it comes to there, for sociology it comes to there, and social work just a tiny little bit at the top there. So these are papers that use census. In England we have census data on every child in school since 2002. We collect national pupil census data, which gives you all the information you could possibly want about their performance on national tests, and a lot of contextual information about their background and the school that they go to. So that we have data sets, annual data sets that contain 7 million cases of students. It's a huge source of data. We also have large numbers of national surveys. So government surveys on young people, on crime, on health, on the environment, and so on. So the potential for using this data is huge. There is so much of this data being produced, but in social sciences, relatively small amounts of it are being used. In Britain, we have 3 huge cohort studies that have followed people from those being born in the late 1950s, in the 70s, and people born at the start of the millennium, which generate vast amounts of data that is freely available for people to analyse, but a relatively small proportion of published journal articles actually draw upon this data, particularly in areas like social work. Sociology and education are more similar, so around about there. And again, in education, it tends to be used by a relatively small group of people, those people who tend to do quite complex work with big data sets. There's very few people who sit in the middle. So it's a relatively underused technique, despite the fact that there is so much of this data available. And what I thought I would do, I would give you a couple of examples of how I've used these sorts of numbers in my research. And the first example comes from work that I did for my PhD. And the second example is about kind of STEM recruitment. By STEM, I mean science, technology, engineering, mathematics. We have a crisis. We have many crises in education in Britain. But these are 2 particular crises. I could have added teacher supply, school qualities, and off we go. But the recruitment, we have a crisis in terms of not recruiting enough scientists and mathematicians. And I'll show you how I've used secondary data to scrutinise that in a moment. But here are just some quotes about this idea of failing boys. It is particularly white boys now. It varies. It's usually some boys of some sort. But at the moment, we're concerned about white boys, white working class boys, partly because students from many ethnic minority groups have improved their performance quite considerably recently, although that doesn't mean to say that students from all ethnic minority groups are successful in school. But at the moment, the focus is on white boys and this notion of underachievement. I mean, what do we mean by underachievement? And if we need to work out what we mean, how do we measure it? How do we decide what underachievement is? Is underachievement the same as low achievement? Well, no. Because, you know, somebody who could be expected to get all A's in an assessment, in an exam, could actually come out with all C's. And you could argue that getting C's is not necessarily low attainment, but if they were capable of getting A's, then presumably that's under-attainment. Somebody who was capable, who did work really, really hard and came out of an examination with D's and E's, that's perhaps low attainment, but if they've worked really hard in order to get those grades, then it's hard to argue that they're under-attainment. Anyway, that's kind of a separate point. But it's this notion of failing boys really informed education policy at the very late 90s beyond. And it was often linked to a crisis of modern masculinity, the place of men in the labour market, kind of post-industrial state of the economy and so on. The idea that schools were dominated by women, that we were using coursework. So there were lots and lots of explanations that were put forward for this sudden, catastrophic failure of boys to excel in school. But if you look at the data over time, you can actually see that there was never a golden age at which boys outperformed girls in many subjects in school. One thing that examination boards are quite good at is hoarding data, but often only split by male-female. It's a bit harder to get breakdowns in terms of poverty or ethnic minority groups, but you can get plenty of data on the performance of boys and girls. So if you were to look all the way back to 1970, and this shows you the difference in attainment in English language assessment between boys and girls. So that's 40 odd years of data. That line is pretty flat. I mean, it bumps around a bit. But there was never a time when girls outperformed, when boys outperformed girls in this particular assessment. The way that I've done the calculation here, achievement gap, is simply to compare the proportion of boys and girls who were entered for the exam compared with the proportion of boys and girls who got a C pass. It's a straightforward technique. It's using data on all pupils, and that data, most of this data I found in the bottom back of a cupboard in the exam board's offices. I went to the exam board because often the data is only available electronically from the late 80s onwards, but to get further back you've got to do a bit of detective work. So often a lot of secondary data analysis spends a lot of time hanging around in the dark, dusty corners of libraries where no one else ever goes, or in backs of cupboards. And I've done that many times and photocopied to try and get that sort of historic view over, well, how long have these patterns existed? The position of the line tells you that girls outperform boys. If it had been a negative value, then, and so on, it's just the way that I put the numbers into the equation, isn't it? It's quite a straightforward equation. But it tells you that there's an achievement gap of around about 15%, but that gap has been pretty flat. That's English language. Now, English is a subject that girls outperform boys in, and I think it's the same in Pisa for most countries. But there's never a sense, this boys' underachievement was not something that's a new phenomenon. If you can, I mean, there are problems with assessing exam performance over time, as I've hinted at before. But even with that in mind, and even if you look at it over the most recent period where, you know, exams have not changed a huge amount, there is nothing to suggest that, you know, there is a golden age where boys were doing very, very well. And if you did the same for mathematics and science, the graph would look slightly different, but the lines would be flat. So this notion of a failing boys, you can just by this simple way of producing data, just looking at percentages, comparing, and this isn't even individual data, this is just aggregate scores over time. It gives a very simple but powerful picture about what's actually happening. I used this approach in part when I did my PhD. And I also did a survey, and I also talked to people. So, you know, I use the 3 different method approaches. So it's the idea of you combining different methods in order to answer your research questions. And that idea from moving from the big pattern, so this is national data over 40-odd years. I've updated it. I didn't just do my PhD in 2013. I updated it to bring it up to date. But this idea that you get the national picture, the big data, then I narrowed my focus to a survey of about 3,000 students. And then I narrowed my focus to around about 50 students where I went to talk to them. You know, and that's a neat approach, I think, especially when you're doing, well, to do any piece of research, but for doctoral work, I think it works particularly well. You know, moving from the large scale down to the small scale. And that's when you're combining different approaches and combining, you know, different methodological approaches. And this approach, which gives a very powerful indication of trends over time, it's very straightforward. You know, it takes a while to get hold of the data, but once you've got the data, the graphs that you can produce are quite powerful. The other example is around STEM shortages, and this is something that I'm working on at the moment. Here, these are some headlines that give an indication of the concerns around the recruitment, training, and retention of scientists and mathematicians. Okay, and they're fairly powerful. And as we often find in education, and perhaps in other areas of social policy as well, this is not new. This is something that's been around for a long time. At the time of the First World War, we had a neglect of science committee where we were very concerned about the lack of science education in schools. For as long as we've taught science in schools, we've had a crisis. And particular concerns at that time about the scientific knowledge of politicians. And that's another area of interest. So, but usually it takes, the concerns that we have sort of takes 3 forms. We don't have enough people studying it. There aren't enough teachers, and the ones that we do have are not great quality. And we have a shortage in higher education. And so these tend to be the same sort of arguments that are rehearsed, well, as you can see, for some considerable time. And that's it's quite interesting when I tend to work on sort of different policy problems in education. It's quite interesting to know, is this new? Is this something that has existed before? I mean, Robert Slavin, who I guess you might be familiar with, he's an American psychologist. He talks about faddism in education being a fad. That, you know, the idea that if you wait around long enough, the next, you know, it'll come back again. So it's a bit like fashion. If you decide you're going to wear flares for long enough, soon enough they'll be fashionable or whatever. But, you know, education has that sort of reputation, and you can see this. I mean, in Britain we have ongoing debates about inclusion of children and young people with special education needs. Should they be included in mainstream schools, or should they be educated separately? And the pendulum swings one way or another. And so it's always interesting to take that kind of historical perspective. With science shortages, as you can see, they've been around for some time. That does not mean that they are no longer important. And you have this idea, again, of science and science education as being central to our economic competitiveness, and how important science is for sort of global economy. And science subjects, and by science I mean quite broadly engineering, technology, mathematics as well, are quite privileged in terms of the time that they're given to in schools and in universities. When the national curriculum was introduced in England and Wales in 1988, it was decided that 20% of the curriculum should be devoted to science. And that's quite a chunk of the curriculum between up to the age of 16, by which students have a freer choice of what they want to learn in school. So 20% of the time in the curriculum was set aside for science, and that has increased. Now, with more schools offering, with the national curriculum, lots of schools taught 2 GCSEs, chemistry, biology and physics, were mixed into 2 examinations. Now the sciences are expanding, where you would do chemistry, maths and physics. So the amount of time that's been spent in science has actually started to increase in schools. So these are quite privileged subjects. They get enhanced funding in higher education. In England, there's been quite a lot of cuts in terms of higher education funding, but the sciences have been sort of ring-fenced. So these are privileged subjects, and understandably to some extent. So I was interested in the extent to which we do have a crisis in terms of participation. In 1988, with the national curriculum, science was made compulsory up to 16. Okay? When students reach the age of 16, they can choose to do A-levels, which is a 2-year course for most students who want to go to university. There are other courses you could do, but most students do A-levels. So this shows you the numbers of people who've studied A-level physics since the A-level began back in the 1960s. And the white line shows men, and the green line shows women. In 1988, the subject was made compulsory up to 16. That had very little impact on participation at the next stage. So you had to study it up to 16 in order to study it for A-level, okay? Science is one of those subjects where, if you choose not to study it beyond a certain level, then it's unlikely that you're going to pick it up a bit later. But that's had very little difference on the numbers participating. Huge amounts of initiatives, especially to get more women to study the subject, both in schools and in universities, has had very little impact. More people are staying on in school beyond the age of 16. In 1972, they raised the school leaving age to 16. Very little impact in people studying at the next level. Now more and more young people stay on in school beyond 16. They're not studying physics. So these are subjects that have had a huge amount of government intervention, a huge amount of focus on increasing the people who do it, but it's had limited effect on the numbers. We don't know what would have happened to these numbers had these interventions not been in place, but it's very difficult to say that they've actually made a difference, particularly amongst the number of women who study physics at A-level. If you want to study physics at university, or many of the subjects that are associated with physics at university, then you pretty much have to have studied this at this level. So, and if you don't study it at A-level, then that route is closed off to you, largely. There are very, very few exceptions. Attainment is not a barrier to people studying these subjects, though. This graph gives the same information as I did for the boys in English. It looks at the achievement gap, but here the gap between men and women is much closer. The way I put the graph, the positive, the red line there, shows that women are slightly better, achieve at slightly higher levels in physics than men do at A-level. So you've got girls studying the subject, and they tend to be quite bright, and they tend to do quite well. But in terms of widening it beyond that to other girls who might be interested in studying the subject, that's been very unsuccessful in increasing those numbers. So the idea, I think, being that people who would have studied the subject are bright, engaged, likely to stay on in school beyond 16 and would have studied the subject anyway. There is some evidence to suggest that the girls are getting better. You can see the line has kind of bumped around a bit. But even so, it's only around kind of a 5% a kind of a head start that the girls actually have, a 5% achievement gap. The gaps are not big. It's not the case that the boys who choose to do physics are doing really, really well and the girls who are doing the subject are not. So I would have said arguably girls are doing slightly better at the subject, but they're not studying that subject at the next level. They're not taking that subject on at university. So the next stage that I looked at was students going to university. Sorry, I've got lots of graphs, but it's kind of a best way in which I can present this information. But the numbers behind this, again, this is straightforward numbers, but the graphs are quite powerful in demonstrating the, the points that you want to make. And often with this, it's usually flat lines. The top purple line, so these are the students who study these science subjects at university, okay? And this goes back from 1986, which is the first year that you had good data on university entrance. The numbers of people who go to university over this period have quadrupled. This is undergraduate students. They've increased hugely since the late 1980s. If you define science very broadly to include subject, medicine, dentistry, mathematics, geography, psychology, sports science, technology, engineering, computing, and so on, around about half of people who go to study undergraduate study a science in some form. So, people are studying science, but they're not studying the elite sciences. They're not studying physics, chemistry to some extent. Mathematics, math fares a little bit better, but they sit on engineering. You can see the blue line. This is the physical sciences. They're not increasing the numbers. The numbers are reasonably flat. So the physical sciences would include subjects like physics, chemistry, environmental sciences, and so on. If there has been any increase in the numbers of students studying these subjects, it's been in subjects like environmental sciences. Subjects that have become a little bit more diverse, non-traditional subjects, subjects that maybe have become a little bit more sexy in terms of what they offer or are perceived to be. In 1986, around about 3,000 students studied physics at undergraduate level, and they still do. So despite almost a quadrupling in terms of the numbers of people who go to university, and despite the resources that go in terms of financing these courses, they've had very little impact on the participation data. Engineering is another example. Around about 10% of engineering undergraduates are female and have been over the last 30 years. Despite national programs to encourage more women into the subject. If had these programs not been in place, then we don't know what would have happened. The numbers may have decreased even further. But there is no evidence to say that they've had an effect on increasing numbers. So there could be a suggestion that, despite all these initiatives to try and make the sciences more attractive, that people are not studying those subjects, they're studying other subjects, even between the huge umbrella of sciences, but they're not studying the subjects that policymakers consider to be important and vulnerable subjects. Just I've got a couple more of these and then I'll bring this to an end. So this just gives you an indication of women. Okay. These are, so we have quite big gender differences, as I've already hinted at, in terms of participation. 10% of women study engineering subjects, the green line, and have been for some time. Biology, the red line on top, much more likely to be dominated by women. Psychology in particular is an area that has increased hugely. Sports science has also become very, very popular, but that's a little bit more gender neutral. There's plenty more boys studying that subject. What happens when they leave university? Remember, we have a crisis, or a purported crisis, in terms of recruitment, particularly amongst engineering. This gives you an indicator. These are the graduates who are unemployed 6 months after graduation. This data is based on the whole population, so all undergraduates. And then when students leave university, 6 months after they've left, they are asked by their institution to complete a survey indicating what they've done. The data isn't perfect. The response rate is about 80%. So it's not bad for a population survey. And this tells you the students who are unemployed 6 months after they graduate. It doesn't include those students who have taken a year out to go travelling or whatever. They're not considered to be unemployed. And you can see that two of the largest groups of people who are unemployed are computing and engineering graduates. Now, this doesn't mean that they're going to be unemployed a year after graduation, but as a benchmark 6 months after graduation, in comparison with students in many other fields, that's quite high. And also what's interesting is that a large proportion of engineering and computer science undergraduates don't stay on for further study after graduation. They do go and seek employment. The figure, for example, for physical sciences would show that about 40% of physical scientists stay on to do master's or doctoral training. That's not the same for engineering and computer scientists. They're more likely to leave studying. But you can see that, around about 15% of computer science graduates are unemployed 6 months after graduation. I don't know what they are doing a year after graduation, but certainly at that 6 month point. And yet, we have a policy that encourages more computer science teaching in schools around computer programming skills in primary schools. And there's a huge kind of policy drive to get more and more kids in schools to study computing in school. And that's fine, because, teaching primary school kids how to write computer programming is an important and valuable skill in terms of, developing their pedagogical knowledge, problem solving, etc. And that's a good reason why it should be taught in schools. However, it's not a good reason for teaching it in schools if we want to generate more computer scientists further down the education pipeline, because the likely chances are that there will be no jobs for them if you look at this kind of rates of unemployment amongst this group. And this, of course, is on top of this, there are groups of people who are taking non-graduate jobs, which I'll talk about in a minute. So there's a real tension here between how we decide what is the best education system to offer and the extent to which our education system is a preparation for the workplace. So by all means teach computer science to kids in school. There's useful skills, it's an interesting topic. It's the same, there are many, many ways to study, why you should study science, even if you don't become a scientist. But it's that notion that, as a direct preparation for a job, and the clear link between education and the economy, that's where arguably the tensions lie. And if you think about the ethical issues of training more and more people, encouraging more and more people to go to computer sciences, to incur more debt, now the fees to attend higher education in England are amongst the highest in the world. There is a sort of a moral obligation here. You're encouraging people to study these subjects, but if there are going to be no jobs for them, then arguably that's problematic. This is just, I think, my last graph. This just gives you an indication of graduates who are studying graduate and non-graduate jobs. The dip, you can see the figures dipped around 2008. So these are those who go into jobs that will be considered the jobs a graduate would do. So these are undergraduate jobs. The little dip coincided with the sort of recession and downturn in 2000, and that started to recover. So you can see that engineering students, so this offers some support for the suggestion that there is a demand for education undergraduates. However, apart from these people who go into those graduate jobs, there is a significant proportion who do not, and who are unemployed or who go into non-graduate jobs. Biology is also quite interesting. That's the orange line, and that is the proportion, so only around about half of biological science graduates go into biological science graduate jobs. So as science professionals or technologists and so on. Or even not in the field. This is not necessarily about the science field. They could go and work, as librarians and so on. So jobs that are considered to be graduate jobs. But biology is quite interesting because that is an area that has seen some increase in numbers in terms of studying the subject at university. But that has not really been reflected in their employment data in terms of graduate jobs, which it remains amongst the lowest of all the students who are all the STEM undergraduate posts. So there is a suggestion perhaps that subjects like biology, where more people have gone to study the subject, they're not actually getting the graduate jobs, so there may not be the graduate jobs there for them. So there's that tension between encouraging more and more people to go to higher education and the expectations that they have of securing a good job at the end of it. So I appreciate that this topic may not be of a huge amount of interest to you, but it's quite an important topic in terms of policy and in terms of how we decide how to allocate our resources in education. But these graphs are quite interesting. They don't tell you the whole story, they tell you a part of a story. But the point that I want to make is that the numbers behind these are really easy to put together. This is not hard sums or stats or anything. So you can do some quite important, powerful work using relatively straightforward techniques and relatively straightforward data. I mean, that's the key point that I want to make. And you know, a lot of my work, so it kind of focuses on this. I did a presentation a couple of weeks ago where I kind of presented a lot of this stuff. And a student came along, she'd recently done her PhD, and she did a really good presentation. She was excellent, but lots of sophisticated stats on a very small sample. And I did come away thinking, oh dear, you know, I'm doing the easy stuff here. But I still think that the kind of more straightforward stuff is very powerful and also very, very important. That's not to say the hard stuff and the complex analysis is not important as well. It's that middle ground, you know, to connect the sort of the two camps, as it were. And that's the sort of area that I'm kind of focusing on. The next stage of our research on this topic will use cohort data. So I said earlier, we have some big cohort data. So there's surveys of, so everybody born on, I think it was something like the 2nd of April, or in 1 week in it, the first week of April in 1970, everybody born in the UK during that week was invited to take part in a cohort study. The numbers, not everybody was included. I think there were probably around about 20,000 people were included, and they followed them throughout their lives so far. So they follow up surveys every 4 or 5 years. They get in touch, they ask them questions about what they're doing, their views of the world, you know, what jobs they've got, what qualifications they've got. And so they've got this snapshot data on an individual's life over a 40-odd year period. And the same information for people born in 1958. So the next stage of this piece of research for us is to use that data to look at the types of degrees they did for those who went to university and the types of jobs they have. Because we want to know, do people who do a science degree at university stay in science jobs? And if they do they earn more? Or do they move out of those jobs? Are those jobs sort of short-term? You know, you hear lots of stories about people with doctorates in the sciences having sort of short-term jobs, job insecurity, relatively low pay, not a particularly attractive early career job. So to what extent is that reflected in this sort of cohort data? So again, it's all secondary data. This will be working with individual level data, so we'll be working with thousands of cases. It's going to be harder because the data's got lots of missing, people drop out. You know, the dropout is not going to be random, people drop out for a reason. You could say perhaps that the people who drop out are going to be less successful than the people who are willing to talk to researchers about how great their lives are. So, you know, there are some more challenges in doing that analysis, but again, it's using secondary data, and it will give us a picture about the state of employment in science subjects that hasn't really been examined. And it always surprises me that nobody's looked at this sort of data. There's lots of work on, you know, how shortages in sciences and so on, but very little empirical work that actually sort of gets to the heart of it. And that's the work that we're going to be doing next. Before I leave this topic, I just wanted to mention, I said a lot about this crisis in STEM recruitment. I've said a lot about the money that's involved. I've given you some examples of where we might challenge whether this is in fact a crisis or not. Quite recently, the House of Lords, the sort of high unelected office in the UK, had a committee which investigated this shortages. And their conclusion, it was remarkable, was that actually we don't know because we haven't got good enough data to find out, which come in at the end of a decade-long, almost a century-long debate about a crisis. I thought was quite remarkable that we need better data. Is that sort of conclusion? We need more research and more money. But there you go. So I thought that was quite shocking that after all this time, they're admitting we don't know whether. But you can see from the data that I've presented to you, their conclusion was correct. But yes, we need to engage with this data in order to present those findings. When I teach a lot of undergraduate students and doctoral students, but I often teach undergraduate students about social justice issues in education, and I rely quite heavily on using secondary data in order to do that. And this is just one way in which I kind of illustrate that. This is about social inequalities. This is the Central Line, Tube Line in London, and if you've been to London, been on the Central Line, probably not a very pleasant experience, particularly in summer. But this is kind of a snapshot. This is the sort of west part of London over here. Then we've got the east part of London here. This is the middle bit, Oxford Circus, Bond Street, Marble Arch, Notting Hill, areas that you might be familiar with. But this is not my idea. I pinched this idea from Danny Dorling, who writes a lot about geography and social inequality. But he identifies 3 areas. And again, this is using secondary data in teaching as a way of kind of illustrating things that are quite powerful. So he identifies in blue an area to the west of the centre, green an area in the centre, and then this is kind of an area over in the East End, which is a much more working class area. And he talks about life expectancy. So a person living in the blue circle has a life expectancy of 80 years. And if you trundle along the tube line a little bit further into the centre of London, people who live there can expect to live a further 5 years. And if you pass the centre and go out again to the east, life expectancy drops. So the link between where you live, the geography, and life expectancy, I think, is quite powerful there. And a similar one about earnings. So these are weekly earnings. People who live in the kind of affluent areas in the centre, around about Holland Park, Notting Hill Gate, where houses are incredibly expensive. They have longer life expectancy than those who live in the poorer areas. It's a kind of a neat way of illustrating powerful social differences using secondary data. This is an example. I'll just talk very briefly about this. I give this as a problem for my undergraduate students. This is a map of a British city. The dots are the secondary schools. And I give them a lot of information on these schools in terms of exam results, pupil composition, type of school. And they have to characterise the schools, and they have to decide which are the more advantaged and which are the least advantaged schools in terms of however they want to define it. And basically, I've taken this slide from a discussion that I gave to them a few weeks ago. What basically I get them to do is to identify the yellow schools, which are the successful schools in the leafy affluent areas, and the purple schools, which are the schools in more challenging circumstances, low exam results, and so on. And I ask them to find a solution. So they have to characterise the population, and then they have to find a solution, which is quite. And so this is a kind of an activity I give for undergraduate students, where they have to interrogate the data themselves. So just to sort of draw this to a close, and be interested in hearing your thoughts, I would kind of sum up the approach that I use as a sort of a political arithmetic approach, which has quite a long tradition in terms of education, sort of social research. It's political because it links to policy, but it's not advocacy. I think that's quite different. I mean, I have lots of colleagues who would consider themselves to be advocates. I'm certainly not an advocate. I said at the beginning that it's a very interesting time for education policy in England. I have personal views on the way in which education policy is changing, but I'm a researcher, and although my personal views will be there, I think the important thing is that you're guided by your research questions and so on. I wouldn't say that you can be wholly objective, but I certainly would argue that it's difficult to be an advocate, and the place of advocacy research is perhaps a discussion for a different time. Arithmetic because, of course, you use numbers. But what's clearly linked to it is that it's not complexity in the numbers. It's often using quite large data sets, but the analysis can be relatively straightforward. It's that idea that you don't squeeze the pips. A colleague of mine always uses that term. You've got your data and you're analysing it and you're analysing it and you're analysing it, try more and more complex ways to try and get something else out of that data. And I tend to look for broad patterns in data that are fairly stable or unstable over as long a period of time as possible. Much of the shape of education research in the UK is influenced by school-based research. I'm talking particularly about what goes on, research that goes on in school, is often linked to policy, and it's often linked to what goes on in schools, and schools largely, particularly state schools, of which 93% of schools are state funded, is linked into high stakes testing. So however you slice it, the work that we do as academics is linked in some way to testing in schools. And the data that's generated by those tests, what is done with the data and the extent to which that data is held up to scrutiny. It informs decisions on school policy, teacher quality, as well as the direction in which education policy is going. And in those tests, I would include Pisa. High stakes for schools, perhaps, but not necessarily high stakes for individual pupils. There is also that tension, who is it high stakes for? There are concerns over the interpretation and reliance on such data. You know, and there are colleagues who would not engage with such data because it's flawed. You can argue that that data is flawed, but you can't not engage with it, I would argue. I've talked a bit about the role of numbers in education and in education research. This is kind of generally about education, but it's always coming back to what happens within education research and the need to engage critically with their use. Not necessarily in terms of analysing lots of data, but in terms of consuming data as well. And there is, I would argue, responsibility on behalf of people who kind of heavily involved in statistics to communicate their findings to a more general population. And a lot of the work that I do is that notion of secondary data analysis in the political arithmetic tradition, that idea of using large-scale data to kind of map change in policy, in society, and to link that to, you know, so what can be done about it. And as an addition to that, to follow it up with more small-scale work. That example that I gave about moving from the large scale down to the small scale is quite a neat approach, not just for doctoral work, but I think for, you know, other work beyond that. I think that's it. But thank you.